Let us talk about what is the monotonic transformation. So what is it that we're going to cover in this recording? We're going to talk about what is the meaning and the definition of monotonic transformation. We're going to check how you can check whether some transformation is a monotonic transformation or whether this transformation is preserving the order of preferences. And then we'll do a very small proof that whether you find out the MRS of the utility function or its monotonic transformation, that MRS will remain same, right? So let me just start with one example. Suppose uxy is equal to xy. That's the utility function which is given to you. And there are two bundles. Bundle A, in which x and y is 1, 2. So the utility from bundle A is 1 into 2, which is equal to 2. There is bundle B, in which x and y is 2, 3. And the utility which you get from bundle B is 6, right? So you know this, that consumer is going to prefer bundle B to bundle A because the utility which it derives from bundle B is more than the utility which it derives from bundle A. Let me write that. So consumer prefers bundle B to bundle A as the utility which you derive from bundle B is more than utility which you derive from bundle A. Now suppose what you do. Now you multiply this utility function with 5, let's say. Supposedly I've just multiplied this. So now suppose we multiply uxy by 5 to get u1xy as 5uxy. That means 5xy. So we have transformed the utility, right? Now again let us see what are the utilities which we are getting at bundle A and bundle B. So bundle A was xy, and the utility in the transformed utility which you're getting from the bundle A is 5 into 1 into 2, that's going to be 10. Bundle B is 2, 3. So the transformed utility which you're getting from bundle B is this guy, 5 into 6, which is 30. So still consumer prefers B to A, since the utility which you get from bundle B is more than the utility which you get from bundle A, even though it is a transformed utility, but the preference ordering is maintained. So you can add, you can subtract a fixed number, utils from the utility function, and it is not going to change the ordering of the preferences. One thing is for that, one thing is for sure, right? Then you can also multiply this utility by some fixed number. Again, the preference ordering is not going to change. So how do you say that something is a monotonic transformation? You say like this, that fu is a monotonic transformation that transforms each u into some other number fu in such a way that preserves the order of the numbers in the sense that if u1 is greater than u2, then f of u1 is greater than f of u2. So if the original utility is, say, u is equal to xy, and the transformed utility is f of u, which is 5u of xy, that is 5xy, then you say that fu is the monotonic transformation of u. So fu represent the preferences in the same way as the original utility. So that's what you meant by this, that is fu represents the preferences the same way as original utility, right? Okay, now let's check how do you find out whether something is a monotonic transformation. So can we just use some method to check whether something is a monotonic transformation or not? So let me just write few points first, or just checking whether transformation preserves the preference ordering. So checking whether transformation preserves the preference ordering, right? So how do you say so? So if you're moving away from the origin and your utility is increasing, the number assigned to the utility that is increasing, you can say that the preference ranking is preserved, right? So you mean this, as long as the number assigned to the utility increases as we move away from the origin. I'll give you an idea what exactly is meant by this. The preference ranking is preserved, right? So if supposedly if you have u is equal to something, right, and then you transform it, and the indifference curve of the transformed utility is steeper or flatter, something, then you can say that yes, I mean, it may not be the monotonic transformation, right? So the slope, the shape, it should remain same of the new transformed indifference curve as well. So what do you mean by this is this, that is, if the transformation makes indifference curve steeper or flatter, then ordering of bundles on new indifference curve will be very different from the original ordering of those bundles. I know that some of you don't like to write this much, but that's the way I think I like it to be taught. So we explain something and then we write it, and you write it in your register. So I always think it's better to tell you everything, whatever we know. And you are, so when I'm teaching, I'm assuming that you are sitting with your notebook and you're writing alongside me. So that's an assumption in my head which is always going on. So definitely, I mean, I'm not, these videos are not to be seen just for means you just want to find out one question. No, I mean, there's a complete course which is going to be taught in this fashion. So my assumption is that when I'm writing, you are also writing. And this is what I have seen over the years, that if you write it in your registers alongside your teacher, things become very, very clear to you. They become somewhat ingrained. So I don't come unprepared completely. So I also write in my register and then I make you understand. So you also have to do this, and you do not have to stop at this. You can always replenish whatever, or you can just increase, or you can just give few more examples from your book. So whichever book you're following. So just see how Varian would have done this, or there must be some test papers. So your midterm exams or your final exams or your university exams. So they might have asked the question based on this concept as well. So just see, can you answer that concept based on whatever we are doing right now? So it will also help you. But the only thing is that some of you might be thinking that why I'm writing this much of English, because I think the things have to be taught slowly, and my assumption is that you're also making notes side by side. So some of you, I'm sure, may like it and some of you won't. But whenever anything is taught, it should not be taught in a haste. You should be taking your time. So when we were in D school, our professors used to write almost everything. Everything. And from there, we also got this habit of writing out everything. So I revere a few professors, whatever they taught us. I mean, it is still in my head somewhere. Anyways, what I was trying to tell you is that if this transformation if you're going to transform the bundle, and if that transformation is going to make the IC steeper or flatter or something, then this may not be a monotonic transformation. So what do you mean by this? That is, if MRS at any point does not change, right, then we know that we have the monotonic transformation. So one, the form of MRS doesn't have to be changed. So if you have u is equal to xy and you get the MRS which is y by x, and you transform this utility, and then the MRS should remain as y by x only. And the MRS at any point, so you take up a slope, you take up a ray from the origin, and so the original utility, original indifference curve and the new indifference curve, the MRS, it should not change along that ray, right? So what you can probably say is this: so u is equal to xy beta. What is MRS? Is mux upon muy, which is y by x, that is u1. Is then another transformation of xy, which is, let's say, 5xy. So MRS is still what? Mux upon muy. You have done this in the earlier recording, how we are getting this mux upon muy, which is 5y upon 5x, which is y upon x, which is y upon x. So MRS is same, the shape of ICs is going to remain same, right, for both u1 and u2. So you can say that yes, u2 is the monotonic transformation of u1, right, and they represent the same set of preferences. So you might just write somewhere, because MRS is same, shapes of IC are same, for both u1 and u2. So you can say what? That u2 is the monotonic transformation of u1. Summation of u1, and both u1 and u2, they represent the same set of preferences, right? They represent the same set of preferences. Well, I can just write that. So let me just write this. So by definition, a monotonic transformation must preserve the ordering of the original utility function. So if f is a monotonic transformation, then for any AB bundle, if UA is less than UB, then f of UA is also less than f of UB, right? So when you find out the MRS would mean that the slope of the inference curve at that particular point, right? So one more point, but since monotonic transformation will not disrupt the ordering of utility all indifference curves would be preserved through the transformation. All indifference curve would be preserved through the transformation. Therefore, you can also say that MRS is also preserved. Therefore, you can also say that MRS is also preserved. So what you can show is this. So MRS of the utility function u is what? Del u by, you can just write du by dx upon du by dy, right? And if you just transform this u to f of u and then again you take the MRS, then it would be what? df by du into du by dx. So what you are saying is this. Now you have f of u beta, or you can also say f of u of x. So if you want to find out the marginal utility here, so you need to find out df by du and then du by dx. Chain rule. All upon df by du to du by dy, right beta? So what do you have? Say for example, if you have f of uy out here, df by du into du by dy. So what is it that you can write? You can write dx all upon this du cancels, and this is nothing but this is the function of u, na? U. And what is this? This is nothing but MRS of the transformed function. This is nothing but the MRS of transformed function. So I think I've given you a few examples and I've given you the meaning of what the monotonic transformation is. Now you can read your book. I think if you want to read a Varian, it must be given somewhere in chapter 3. And if you're reading Nicholson, again, maybe in chapter 3, 4. And I don't know about Rubenfield and Pindex. So there are few references. So, but my advice is that you follow just one book. If you're following Varian, just follow Varian. If you're following Nicholson-Snyder, you follow Nicholson-Snyder, or you're following any book, just follow one book. So you can append your notes with these explanations. Thank you, beta.